Today I'm going to discuss about the topic application of finite automata in networking. These are the contents I'm going to discuss now. Introduction of finite automata. Finite automata is a mathematical model that consists of states, transitions, and inputs. It is used to recognize patterns in input sequence and can be applied in various fields including networking. In networking, finite automata can be used for packet filtering, intrusion detection, traffic shaping, and more. It allows for efficient processing of large amount of data and can be improve network performance. Types of finite automata. There are two main types of finite automata, discriministic and non-discriministic. Discriministic finite automata DFA have a unique transition for every possible input and can only be in one state at a time. Non-discriministic finite automata NFA can have multiple transitions for a single input and can be in multiple states at once. In networking, both types of finite automata can be used depending on the application. DFAs are commonly used for routing protocols, while NFAs are useful for intrusion detection systems that need to analyze multiple sources of data simultaneously. Let's consider an example of DFA that recognizes a binary string with an even number of zeros. The states are Q0, Q1, the symbols are 0, 1, the start state is Q0, the accepting state is Q0, and the transition function is as follows. Let's discuss an example for non-deterministic finite automata. We can see that from state Q1 for input A, there are two new states Q1 and Q2. Similarly, from Q0 for input B. Thus, it is not determined or that with a particular input where it go next. Hence, this FA is called non-deterministic finite automata. Formula definition of NFA. Delta Q cross sigma tends to 2Q, where Q is finite set of states, sigma is finite set of the input symbol, Q0 is initial state, F is final state, delta is transition function. Application of finite automata in networking. One of the most common applications of finite automata in networking is packet filtering. By using a DFA to match incoming packets against a set of rules, unwanted traffic can be blocked before it enters the network. This can help prevent denial of service attacks and other security threats. Finite automata can also be used for trafficking shaping, which involves prioritizing certain types of traffic over others. By analyzing the contents of packets and assigning them to different categories, a network can be optimized. For specific applications such as video streaming or online gaming. Challenges in using finite automata in networking. Despite there are many benefits, there are also challenges associated with using finite automata in networking. One of the biggest challenges in scalability. As networks grow larger and more complex, the amount of data that needs to be processed increases exponentially. This can be leads to perform issues and delays in processing. Another challenge is ensuring the accuracy of the automata. In order to function properly, they must be designed and implemented correctly, which can be a complex and time consuming process. Additionally, they must be constantly updated and maintained to keep up with changes in the network environment. Future developments in finite automata for networking. As networking technology continues to evolve, one area of development is in the use of machine learning algorithms to improve the accuracy and efficiency of automata based systems. By training the system on large datasets, it can learn to recognize patterns and make more accurate predictions. Another area of development is in the integration of automata with other technologies such as blockchain and the Internet of Things IoT. By combining these technologies, it may be possible to create more secure and efficient networks that can adapt to changing conditions in real life. Examples of finite automata in networking. Some examples of finite automata used in networking includes firewalls, intrusion detection systems, and routing protocols. The, these systems use finite automata to model and analyze network traffic to detect and prevent security uh, threats. Conclusion: Finite automata is a powerful tool for analyzing and processing data in networking applications, whether it's for packet filtering, traffic shaping, or intrusion detection. Automata can help improve network performance and security. While there are challenges associated with using finite automata in networking, ongoing developments in technology and machine learning offer exciting possibilities for the future. As networks continues to grow and become more complex, automata-based systems will play an increasingly important role in keeping them running smoothly. Thank you.